Alright, so 3.2 measures of variation. So we talked about measures of central tendency in 3.1. Today we're going to look at the ability to analyze statistics using how spread out data is. That's another way to analyze how closely bunched together the data is versus how spread out the data might be. The first measure of variation that we're going to talk about is the range. And we talked about the range a little bit yesterday, but the range is just the difference between the highest and lowest value. You take the highest value, subtract the lowest value, and you get an idea of the spread for the entire set of data. That's what the range is good for. The two other types of ways are going to be variance and standard deviation. And they determine how far apart the data is from the mean. How spread out the data is from the mean. So when we talk about variability and how spread out data is, we usually talk about it with respect to the mean. So the bigger those numbers are, the more spread out the data is from the mean. So the bigger the variance, the bigger the standard deviation, the more spread out the data is from the mean. So you should be able to figure out what the line after this is going to be. What do you think the next line is going to say? Correct. The smaller those numbers are, the less spread out, or the closer the data is to the mean. Okay, same idea. So here's the data. If you want to take a picture of this page, you can. There's going to be some other things I'm going to add to it in a little bit. But what I want you to do is I want you to put brand A in list 1, brand B in list 2. If you don't remember how to do that, in your graphing calculator, hit the stat button and then hit edit. And then you'll get to your lists, and I want you to enter that data in there. And then we're going to use it in a little bit. Alright, so the standard deviation, you're going to get questions like this on tests and quizzes. The relationship between standard deviation and variance, okay? The standard deviation is the square root of the variance. Conversely, the variance is the standard deviation squared. Okay, they are related that way, and that's a relationship that you need to know. When we do this, we're not going to do it by hand, we're going to have our calculator do it. Our calculator will find the standard deviation. And I'm going to show you how to find the standard deviation using your calculator. You will need to find the variance from the standard deviation. Okay, and that's what it says. Okay, we're going to use the graphing calculator to find the values. It will give us the standard deviation. We will then square that to get the variance. And so you're aware, there is a sample version of the variance and standard deviation, and there's a population version of the variance and standard deviation. And I'm going to show you the symbolism for them. I'm going to show you which one you're going to use in your calculator, and then I'm going to show you how to calculate the variance after you've found the standard deviation from your calculator. On the next screen, I'm going to start giving you a whole bunch of formulas. At the very end, I will tell you just to take a picture of it. So instead of trying to frantically write down everything that I'm going to show you on the screen, don't. I'll let you know when it's okay to take a picture. Okay? So here's the thing. I'm going to show you population variance formula. I'm going to show you sample variance formula. I'm going to show you the population standard deviation. And I'm going to show you the sample standard deviation. Okay? We are never going to do this by hand for an actual data set. We're going to do it, we're going to use our calculator to do it for us. But I want you to know where it comes from. Okay? First off, this is a lowercase sigma. Okay, this little O with a thing on top. It's a lowercase sigma. This means sigma squared. Sigma squared represents the population variance. We saw this capital sigma yesterday, that means the summation. X is the value, the data value, and mu is the population mean. N represents the number of data values in the population. If you had to do this by hand, like I had to do it by hand back in the day, what you would do, what this formula says, is you would have to take each data value, you would subtract the mean from it, take that difference, and square it. And you'd have to do that for each data value, and then add those up. And then divide by the number of numbers, okay? If you have a data set that was 20, 30, 50 values long, you would have 50 subtractions, and then square all of them, and then add them up. Then divide it by the number of numbers. So to do that by hand would be a real pain, okay? Yes, it's excruciating. The sample variance is essentially the same thing, except we use S for the sample standard deviation, and you square that and you get the variance. The rest of this is the same. You take the mean. Remember, the sample mean had the X with the bar, so you subtract the sample mean from each data value, square it. And this difference is, instead of just dividing by the number of numbers in the sample, number of data values in the sample, you actually subtract one from it. And the reason that they do that is by subtracting one and dividing by a little bit smaller number, you increase the variance a little bit to account for error due to the fact that it's a sample and not the entire population. Again, you're never going to have to do this for an actual set of data. Then the standard deviation for both is the square root of both. Okay, so it's the exact same formula, just taking the square root, and that's that relationship. So now, if you want to take a picture of this screen, you can. One of the reasons I even talk about this is, one, so hopefully you can appreciate the fact that you don't have to do these calculations that are very, very tedious and then could create a lot of errors. The other reason that I want to show you this is that some of you like to go back and look at it in the book, and sometimes the explanations in the book use the formulas, so I just wanted you to be exposed to it. The formula, however, for finding standard deviation variance from a set of grouped data, that is a formula you are going to need to know, and we're going to go through that at the end. All right. Let's go back to our example. All right, and we're going to find the type of problem that you're going to see in your homework. It's going to say calculate the range, population sample variance, and population sample standard deviation. Okay. I'm going to add one more thing to it and then ask you to take a picture of this screen. This is how I like to set this up. So I create the range, variance, standard deviation, sample and population for A, and the same thing for B. If you want to take a picture of this screen, go for it, because then we're going to fill all those missing values in. Go ahead and find the range for A and B. Do that on your own. And fill in the range for A and B. All right, what's the range for A? 50, because what's the biggest number? 60 minus 10. What about for brand B? What's the biggest number? 45 minus 25, okay? That range, okay? So for A and B, there's your range. That's the first part of it. All right, the next thing we're going to do is use our calculator to find the standard deviation. You've already entered brand A into list 1 and brand B into list 2. So here's how we're going to do that calculation. Hit your stat button, okay, and then arrow over to calc for calculate. And then the very first option says 1 var stats. That means 1 variable statistics. Okay, hit enter for number 1.
Wait, I lost you.
On that next screen, after you hit enter for 1 variable statistics, you have to make sure that it's going to do the calculation from the list that you need it to. So let's worry about brand A right now. In all likelihood, the very first line says,
A1.
let's see,
When you're clicking A and L.
no, yours is different. Okay, yours is old.
It's about this.
Yes, okay, so the very first line says list. Make sure it says L1. Okay, it probably does already. Okay, you don't need to worry about frequency list. Just go down to calculate and hit enter. Okay, then you'll get on that screen, you'll get a whole bunch of data. The very first part there says X with the bar, that's the mean. Okay, it's 35, which I already told you. Here's why I pointed out that the mean was the same. Okay, if this is the only value you're going to use to make a conclusion about the data, it doesn't tell us the whole story, right? Because clearly brand A is spread out quite a bit from 35, relatively speaking. But here, since the range is smaller, the numbers are bunched a little closer together. So the mean by itself doesn't tell us the whole story about the data, which is why we look at things like variance and standard deviation. Now, the next couple lines on your calculator we're not going to use, but below that you have S with an X. Okay, that is the sample standard deviation, and then you have that lowercase sigma with an X. That is the population standard deviation. So for list 1 for brand A, I want you to write those values in here from your calculator, knowing that since the data is a whole number, I want you to go one place beyond that. So I want you to round to 1 decimal place for sigma and for S, and to go ahead and write that in. So here's what we've had. Okay, you should have had for sigma, you should have had 17.1, and for S, you should have had 18.7. Okay, the part that you're going to have to calculate now, first of all, how many had that? How many had that on their calculator? Okay, good. What you need to do now is go back to your calculator, take 17.1 and square it to get the variance, take 18.7 and square it to get the sample variance. This is the population variance and the sample variance. So go ahead and square those, and that'll give you the variance, and then write those down. Again, we're still only rounding to one place. We've gotten 292.4 and 349.7 for the population and sample variance. All right. Now again, since the range is bigger here and the data seems to be more spread out here, we would expect these values for B to be smaller than these values for A. Now, in order to find those calculations, what I want you to do is go back into the stat calculate one variable statistics option, and now we need to change the list. So instead of pulling it all from list 1 again and getting the same values, you've got to make it list 2. All right, and so when you hit enter and the first line says list, go over to where it says L1 and change it to L2. And L2 is above the number 2 on your calculator. I think it's blue, and then you hit the number 2. And then that will change the list in your calculator to list 2, and then your calculator will do all the calculations for list 2 instead of list 1. So go ahead and do that. List the standard deviations, square them to find the variances. So go ahead and finish that up. So your standard deviations, population and sample, you should have had 6.5 and 7.1. You square them and you get 42.3 and 50.4. Again, we round to one place beyond the data. And then this supports our conclusion, what we could already tell. This is a small set of data, obviously. Okay? But it's clear that B is bunched a little closer together than A, and the numbers tell that. These numbers are smaller because this data is bunched closer together. These numbers are bigger because this data is a little more spread out. Okay? Now, what I'm going to show you on the next slide is how to do group data. Okay, and just like yesterday when we had group data, we're going to use the midpoints. We're going to use the frequency times the midpoints, but then we have a whole new column that we need to add to the data. So a lot of what you're going to see today, and I'm using the same data that we used yesterday, so the same table that we used yesterday. Okay, but I need to give you the formulas, and these formulas you will need to know. And I know they're going to look super overwhelming and complicated, but they're really not that bad once you get into it. Okay. So here is the formula for, and when we have group data, we only talk about samples. We don't talk about population. We only talk about samples. So this is the formula for variance. Okay? And the standard deviation is just the square root of that. If you want to take a picture of this screen at this point, you can. So you have those formulas, and I will explain what it all means. Let's take a picture of this page instead. This one's actually going to be more useful to us because it has the data there. Again, that table that you see at the bottom is exactly the same as what we had yesterday, except I added this column, the frequency times the midpoint squared. That's the only column that's different. Okay, the rest of this table we actually already have completed, except for this column. And I'm going to show you where they all go in the formula, so we're clear on that. But every time that you find variance and standard deviation from a set of group data, you're going to have to create this table. Okay? So here's what's going on. To find what we're going to do, so here's where it's going to work a little differently than what we did with our calculator. We actually will find the variance first, and we'll find the variance using this formula. Then afterwards, we just take the square root of that number to get the standard deviation, because that's all that really says. So here's the formula, and I'm going to explain it as best I can. So you take the number of data values. I'm going to multiply that by the sum of the frequency times the midpoint squared. This column. We're going to find this column and add it up, and that's going to go here. From that, we are going to subtract the sum of this column squared. Okay? So this column is the frequency times the midpoint. Add those all up just like we did yesterday, but then we're going to square it. And then the bottom's easy. The total number of numbers times 1 minus that. 1 less than that, excuse me. Okay? So let's first put the rest of the table back together. We had already found the midpoint yesterday. We found the frequency times the midpoint yesterday. All that we did yesterday. Okay? The last column, what we have to do is take the midpoint, square it, and multiply it by the frequency. So the very first one is going to be what? When I take the midpoint squared times 1, what's that going to be? The midpoint squared times the frequency for the first row. Hello? 64. Thank you. The midpoint is 8. Square it times 1. All right, the next one, 13 squared, which is what? 169 times 2. What's that? 338. And then you just keep going. Okay? In the interest of time, I'll provide those answers for you. Okay? So again, midpoint squared times the frequency. I need the sum of all of these columns here. I need the sum of the frequency column. Actually, I don't need the sum of the midpoint column. I need the sum of this column, and this column. Also, in the interest of time, I will provide those for you. Take a picture of this screen, please. Now, so the sum of the frequency times the midpoint, that's going to go in here. The sum of the frequency times the midpoint squared is going to go here. The 20 is going to go where n is, and then of course 20 minus 1 is 19. So all I have to do now is plug it into this formula, and I'm gonna plug it all in and color code it for you so you can tell what goes where. All right, so that's where the numbers are going to go. This 13,310 is the sum of the frequency times the midpoint squared. That goes here. That came from here. This number, 490, that we calculated yesterday, the sum of the frequency times the midpoint goes in here, and it gets squared. And then the n is 20, so everywhere you see n, we put a 20 in. Now that we've got it all set up, plug that giant thing into your calculator and see what you get. Okay, here's what you should have gotten. You should have gotten 68.7. So if you guys enter it in your calculator as a division problem, you probably want the numerator in its own set of parentheses and the denominator in its own set of parentheses, okay? Then, to find the standard deviation, all you do is take 68.7 and I would prefer that you actually use 68.7. And I say that, and I feel like maybe I didn't do it that way. I don't know. We're going to find out here in a second. Take the square root of 68.7. What do you get? square root of 68.7 does equal 8.3. That is my standard deviation from a set of group data and my variance from a set of group data. This formula, this process, this table, you're gonna have to recreate on a quiz or test. Okay? The rest of it, you're gonna do on the calculator. When you have the actual data, you'll enter your list into your calculator and do the calculations for you. But if you have group data, you're gonna have to do this.